Hello everyone. I'm really happy today to discuss about my lesson plan about Newton's circular. First of all, I want to talk about my students. They are familiar with some operators and inquiry-based learning. In this lesson, my students have already known about electric vibration device, and in the lesson of accelerated motion. To finish this lesson, I expected my students who during this lesson will remember, understand and remember Newton's circular, as well as inquiry skills such as design of experiment, determine the qualitative relationship, and compare the result of experiment with prediction. My lesson plan includes 3 phases based on inquiry-based learning with experiment. The first one is explicit the problem. In phase 1, I will remind students to an ordinary phenomenon in reality, pushing the trolley. From this example, students can see that the mass of objects and the force acting on it affect the acceleration. And the question is, what relationship among the acceleration, force and mass? The answer must be this relation obey the law called Newton's circular. A equal to F over m. This law said that the direction of acceleration A is the same as the direction of the force, and the magnitude of acceleration is proportional with the magnitude of force acting on it, and inversely proportional with the mass. And from this example, students can just observe the qualitative relationship. But how could we take the particular data to prove this law and examine the relationship closely? And I demand student design of experiment to prove this law with particular data. And now we move to the phase 2, problem solving with experiment. To demonstrate the formula, we have to prove 2 cases. Case 1, A proportional to 1 over m with F is constant. Case 2, A proportional to F with m equal to constant. Let's consider the first case. To do it, I ask students what variable will change, what variable will keep unchanged, and what we need to measure, and students can answer easily. We have to measure A, acceleration A, change the mass, and keep F unchanged. And now I will sketch the design of experiment. We have a cart is moving on a track. and this cord attaching to the long tape. When this cord is moving, it will pull the tape, and the ticker machine will mark on the tape each 0.02 seconds. By measure the distance and the time, we can determine the acceleration A equal to s over 2t squared. But how we can change the mass of the object? It's easily. We add an object on the cord. We can use a pulley. Attaching an object attaching on the cord will fall freely. In this situation, the system concludes the cord, the string, and the falling object, and the force acting on the cord. And the force here is gravitational force. And I have a table. The first variable is delta m, which is the mass of object we add on the cord, and the mass of system, the distance, the time, and important acceleration A. We can do it 3 times to collect the particular data. And now we move to the case 2. A proportional to f with m is constant. We can use this experiment again, but how we change the f and keep the mass unchanged? It's easily. We can change the adding objects here on the cord to the falling object, and we change the mass of falling objects. The gravitational force will change, and we change the force F. And we have to table 2. We have the force F, also S, T, and A. We also do it 3 times. And now I will introduce and do experiment. Watch. We have to make sure that the first wheel parallel with the track. We have
Can you see it?
yeah.
Coming? Because we don't have time anymore. So let's see what you have. Ooh. So how you can analyze this data?
It's because the ink is not good.
Okay, so go there. Please, I have to few comments and only one question. English is the pronunciation is still not as good as I explained it yet. By reality.
Yeah, reality.
Not reality or something. Reality or direction.
I think that direction is another version of
okay.
yeah.
Okay, that's my message there. So direction or direction.
Yeah.
Okay. And when you show a demonstration experience, so you should not block the visions of the audience. So your back is not in front of them, your face mostly. And in really difficult cases, you stand on the two sides of the table, not in front of the table.
Yeah.
And my question is always for this one is, why don't we just investigate the force and the aspirations of the cars on the track only? Why should we have to involve the math also in the system of math to investigate or verify the literacy?
Why we adjust only card?
Yeah, why not?
Because if we use all whole system, we have to verify that F gravitational P equal to M multiply G multiply A, and we have to do round and cannot verify.
I don't get it. For instance, we investigate only the cars. Of course, I will find some way to assert the force over the cars. And in this case, if I will investigate the Newton's second law apply for the cars, so the mass of the car is M, and the density force is F, and the mass of the cars I can measure with a scale, and somehow I can still verify. Why don't you investigate that test?
Why I don't? This is my only card. Because if in that case, the force acting on the card is the first T tensor. Yeah.
What is wrong?
And the first T here, if the string is not stretched and the mass of string is very small, and we can see that the tensor T equal to T here and here and here, and it's equal to gravitational force P. But we don't know gravitational P.
In case we know, but we do not take the mass below into the system. We just investigate the motions of the cars on top of the track, and we see how its acceleration depends on the force exerted on it and depends on its mass. The masses below is just a way to make a force on the car above. Is that okay for this experiment?
I think not okay.
Because the concept of system of mass is very complicated, and that concept will be taught after this lesson. Yeah. And why? So that is a conceptual difficulty for students. So why don't we use more simpler situation where we just only investigate the cause both?
But I think the simple, if we only use the card, we can measure that the F is constant.
Why?
Because if we use only card, we pull the card, and your force is not it's not constant.
Yeah, it's not. It's difficult to remain constant.
Yeah.
I still use the mass to hang it on over the pulley and also the force via the mass over there. And is that okay for the center?
I don't understand about your idea.
No, you use the same setups,
Yeah.
but instead of considering the system of mass, you only consider the card on the top of the track to investigate or verify the
Only the card on the top.
Yeah.
Yeah. But the card on the top, on the first acting on it, not because the card on the top maybe can travel around.
No, I mean that part, the card on the track.
Only the card on the track.
So the
I
card
mean,
on the track, so the mass M in the formula is the mass of the card. The force in the formula is the tensile force, and the acceleration is the acceleration of the
but in this case that you said, the gravitational force will be external force.
If you consider only
Yes, only the card.
on the track, so the external force in this case is the tensile force.
Tensile force, and it's
And it seems okay.
no, I think not okay.
Have you ever talked about that? Have you ever talked about that question?
No.
You read the manuals, and the manual said that you have to take the two masses into account as a system of mass, and so on and so on, and then you simply And that is quite difficult for students to imagine the system of mass as a mass. And actually, two parts of the system move in different directions, right? Because it's difficulties for students to understand the mass and different mass module difference. So it's difficulties, and but we have to do that in order to be sure the force is constant. If you consider the tension force and external force, and we consider only one car, only car on the track, and you know the tension force change over car when the system moves, and we cannot investigate the Newton second law because the force act on the object must be unchanged.
Yeah.
So that is it. But how to change or how to shrink the situation from only one car to the system of cars is quite challenging for teachers. Or otherwise you have to force students to believe that it is the mass, and that mass include two components in itself. But it's quite difficult. So think about that when you have to teach this lesson in reality.
Yeah.
But for the exams, you cannot react to that question quickly, so that is kind of mistake.
Yeah.
Which I think will.
Thank you for listening.
I have another few math to one or two result.
Later. Yeah.
And keep us.
Really?
Yeah.
Now?
Yeah, now. The other come and do that.
And in the meantime, so you bring the equipment on the side or bring the envelope and the data?
Maybe with the same mask and two different box.